Okay, perhaps it would be the last session on foundation settlement, and I have at the very beginning I have mentioned that settlement will be of three components, and elastic settlement we have discussed, then consolidation settlement, and again while consolidation settlement soil can be of two types, normally consolidated, over consolidated, and accordingly how to modify the equation, that also we have discussed, and that is one part to find out total consolidation settlement. And after finding out the total consolidation settlement, sometime we may require that over what time this consolidation settlement will take place, or how much time is required to achieve certain degree of consolidation. So, that also we have discussed, and we have shown some application also, but now I will try to take another problem where so far we have given either in some problem I have taken that where we have C c is calculated based on empirical formula, which is nothing but 0.009 multiplied by liquid limit minus 10. That is one equation, that is one problem we have done, and but I have mentioned that the C c typically can be obtained by using laboratory test data. Laboratory test data means you have to collect the sample and then you have to test it, consolidation test you have to carry out. Consolidation test means what? You have to apply load and then you have to see when there is a no change in the dimension or compression is not taking places, or sorry, if you apply the load and then you see that at some time there is no change of thickness, that means under that loading consolidation is complete. So, like that again after that you apply another load P 2, then you will see what is the end of consolidation for that load, and then if you apply P 3, then you see what is the end of consolidation under P 3, apply P 4 and find out what is the end of consolidation for load P 4. Like that we will get different pressure and for corresponding different compression, and then from there we can find out pressure versus void ratio, and that pressure versus void ratio data if you have, then if you plot in a semi-log curve paper, then you generally know that it will be a straight line, particularly for normally consolidated soil, and from the slope of that line we can find out the C c. So, that is the another aspect I have mentioned, that you can find out the C c from the laboratory E log P curve, but we have not taken any problem. So, now I will be taking one problem where the complete application, that means suppose a clay layer is there, from the clay layer some soil is sample is collected, the soil sample is tested, consolidation test is carried out and pressure versus void ratio is curve is given, and then details of the clay layer is given. So, for that what you have to do, then to find out the consolidation settlement we need to find out initial pressure, overburden pressure, that is P naught. Then because of the loading of the footing you have to find out a delta P, the increase of the pressure, and then while applying the log formula, then we need another term, that is C c. That means whatever E versus pressure data is given, I will plot again and find out what is the value of C c. Once you get all those things, then I can apply finally log formula and get the total settlement. And I will take this problem, then again it is another problem asked, another question was asked, that how much time it will take to achieve this much percentage of consolidation. So, that means application of the degree of consolidation also will be seen here. So, all those three aspect in consolidation will be shown here. So, this problem. So, let us go to the problem. The problem is like this. You can see here a sample of normally consolidated clay was obtained by a Selby tube sampler from the mid height of a compressible clay layer. So, that means this is the clay layer, actually this is the clay layer, and from the mid height suppose sample is collected and then tested. A consolidation test was conducted on a portion of this sample. So, sample might have collected and some portion and then test was conducted, on a portion of the sample, the results of the which are given as follows. That is actually natural void ratio of the clay existing the natural void ratio, that is 1.8, and pressure void ratio relationship are as given as follows, means its table could have been here, but I kept because of the space adjustment I kept here, and you can see pressure 25 kilonewton per meter square, 50, 100, 200, 400, 800, 1600. So, this is the procedure we follow in consolidation test, that each pressure increment will be doubled from the previous one. So, initially 25, then 50, then 100, then 200, then 400, then 800 and 600 like that. And when the 25 kilonewton per meter square pressure is applied, corresponding void ratio is 1.72. When 50 is applied, then corresponding void ratio 1.7, when 100 corresponding, and of course, after application of the 100 pressure, at the end what is the void ratio, that is the one is given here. So, 200 1 point like that, from 25 to 1600 pressure variation was there, and for that E versus P is given. And next actually still we are describing the problem, that problem what is asked is not has come. So, I will go to the next point, next slide. You can see here a footing is to be constructed 1.8 meter below the ground surface. That means so this is 1.8 meter, 1 meter below the ground surface as shown in the figure. The base of the footing is 2.7 by 2.7. This footing dimension is 2.7 by 2.7. It is shown in the figure actually, and it carries a total load of 1800 kilonewton. Q become 1800 kilonewton. It is there in the previous slide, and then compute the total expected consolidation settlement of the clay layer because of the footing load. The clay layer was somewhere here, and some thickness was 2.7 meter, and this is 2.7, this is also 2.7, and water table was in the let me see settlement of the clay layer because of the footing load. How long will it take for 90% of the expected consolidation settlement to take place if the coefficient of consolidation of the clay is 4.96 multiplied by 10 to the minus this one. So, that means, because of this loading, what is the consolidation settlement you have to find out, and for 90% u 90% how much time will take. So, this is the two parts. So, three parts are there. C c is not given. So, from the E p plot E versus log P, I will get C c, then using that I will get consolidation settlement. After getting the consolidation settlement, next what I have to do? I have to find out again u 90% how much time it should take. So, these are the different parts of this problem, and you can see and you can see the problem here, that your 2.7 by 2.7 meter, and then your here actually sand and gravel, here also sand and gravel. So, this is another point while calculating the time you need to use this one, sand and gravel here, sand and gravel here. So, both top layer and above and below the sand and gravel is there. So, because of that it has to be considered as double drainage, and if it is double drainage, then H will become in the equation will be 2.7 by 2. While calculating total settlement will be H equal to 2.7, but while calculating the time, that T equal to C v T over H square, this will be equal to this one. That is one thing to be observed. And so, with this detail actually then let us and when I will find out the consolidation settlement, we required C c first. So, let us go to that first. and you can see now. So, this is actually I have just plotted in the Excel, and you can see this is actually E and this is actually log P. Okay. And E versus log P, actually you can see, as we have mentioned, that initial portion will be little curved and after some time it will be straight line. So, it must be, that means it must be a normal consolidation case. So, then how to find out C C? Then I have to find out slope of this portion to find out C C, and then what I will do? I will find out at this point what was the pressure, and at this point what was the pressure, at this point what is the pressure. Okay. So, these 2 points actually if I locate, P is 200, E was 1.51 and P is 1600, E was 0.95. Then what will be the what will be our C C? C C will be equal to delta E divided by log 10 base P 2 over P 1. So, that means I will put 1.51 minus 0.95 divided by log 10 base P 2 will be 1600 and P 1 is actually 200. So, if you do this, you will get a value of C C equal to 0.62. The first job is done. That means, either you can take a graph sheet, generally you have to take graph sheet when you are in exam hall, because you may not have the plotting facility in the exam hall, or you can take Excel when you normally practice and then you put the value and fit in this form, then you will get a straight line. By observing the curve, you have to first decide whether it is a work consolidated case or normally consolidated. Normally consolidated case, how to know? That you know that initial portion will be curved, but the major portion will be straight line. So, it happens from here to here, actually it is straight line. So, when it is so, then anywhere 2 points you can locate, and from there you can find out what is P 1, what is P 2 and corresponding what is E 1 and what is E 2. So, I took 2 pressure value and corresponding to E value, from there I got C C equal to 0.62. And now, if you want to find out consolidation settlement, then consolidation settlement, let me draw the footing first. .8, 2.7, 2.7, and water table is here only, and if I put dispersion like this, then at this level what is the width? I have to find out. This will be equal to B plus Z, and Z will be how much from here to here? It will be 2.7 plus 2.7 divided by 2, and that gives you 4.05. So, this will be equal to B is 2.7 plus 4.05, and that becomes 6.75. That is one thing. And here actually your 20.2 sand and gravel, this was gamma is 20.2, and here actually it was 17.3. Okay. So, I can find out now, already I have got C C equal to 0.62, and then your P 1 will be equal to 1.8 plus 2.7, this is sand and gravel, and unit weight is 20.2 plus your clay layer, that is 17.3, that is actually 17.3 minus 9.81 multiplied by what is the depth actually 2.7 by 2. So, then if we do this one, then how much it comes? This will be coming 101.01, 101.01. So, P 1 dash effective stress, effective overall pressure before application of the load is this one. Now, I have to find out delta P. Delta P will be equal to how much? I know the load applied was 1800 kilonewton per meter square, 1800 kilonewton divided by footing size at the level of the middle of the clay layer was is become now based on calculation B plus Z, it becomes 6.75 square footing. So, 6.75. So, this gives you a value equal to 39.05 kilonewton per meter square. This is also kilonewton per meter square. Now, if this is the one, then you will have delta consolidation will be equal to C c, that will be 0.62 multiplied by H, actually 2.7 divided by 1 plus actually your E value is given 1.18, 1.18 multiplied by log 10 base, your 101.01 plus 39.05, this is P 1 dash and this is delta P divided by P 1 dash, that will equal to 101.01. So, this one if you calculate, it gives you 0. This will be in meter, 0.110 meter. So, it will be nothing but 110 millimeter. So, this already I have taken one or two problem similar only up to this. Only what is the difference in this problem? I have C c was not given. So, what I have done? I have plotted E versus log P, and from there I have calculated the slope, and that slope is nothing but C c. That C c I have taken here. Otherwise, P 1 dash calculation is similar, delta P calculation also similar, and equation also the same. By using this, I will get a settlement equal to 110 millimeter. So, this is actually first part of the problem is done. Now, I want to now second thing is mentioned that if the coefficient of consolidation is this much, what will be the time required to achieve 90% degree of consolidation. For that actually I will take second step. So, let me go to the second part. Let me erase this and go to the second part. So, you know that footing was something like this. One second, let me draw. This is 1.8 and this is 2.7 and this is 2.7. This is also 2.7. This is, and then sand and gravel here, sand and gravel here. So, that means this is a both way drainage or double drainage system, double drainage system. So, double drainage system, then your H equal to 2.7 by 2 equal to 1.35 meter. Okay, this is one part. Second thing is our calculation depends on T equal to or T 90 equal to C V T 90 by H square. So, that means T 90 means what? Degree of consolidation time factor corresponding to 90% degree of consolidation, and T 90 means what? Time required to achieve 90% degree of consolidation. So, I have used additionally instead of T I use T 90, this capital T also have used T 90. Now, degree of consolidation U is 90%. So, I have to find out T 90, and as I have mentioned that T versus U, there are two such sets of equation. So, it is 90% degree of consolidation, that means it is above 60%. So, I will use second set of equation, that T 90 will be 1.781 multiplied by 0.9333 multiplied by log 10 100 minus u. So, if I put that 1.781 minus 0.933 log 10 100 minus 90, then we will get a value equal to 0.848. You can see exactly for 90% it is the value 848. Now, so I go back to this equation. If I go back to this equation, then I will get T 90 will be equal to T 90 multiplied by h square divided by C v. So, this will be T 90 become 8.848 and h square become 1.35 whole square divided by C v is actually given your 4.96 multiplied by 10 to the power minus 6, and this is actually given meter square per minute. So, that means, you can see here actually there is a meter square and here there is a meter square get cancelled. So, only this minute will come. So, ultimately this unit of this expression will be in minute. So, that means, T 90 I am getting this in minute. So, this calculated value if I put, this value comes in the range of 311, then 588.7 minute. When I am expressed in minute, it is a large value. So, then what I will do divided by 31158.8.7 divided by, if I divide by 60, then it become minutes to hour. Again further if I divide by 24, then it become days, and if I want to get in days. So, if I do this much, then you will get in days, and if the days become very large, again I can convert into month or it can be into year also. So, further I can divide by 30, then it will be in month, then again further if I divided by something, then it will be year also. If I divide by 365, then it will become year also. So, by doing this I will get it will be 216.4 days. That means, this problem whatever is asked, and you can see because of double drainage I have used this half the thickness. So, that ultimately that means, the whatever problem was given, for that problem you will get a total settlement of 110 millimeter, and 90% means 90 into 110, that means 90 multiplied by 110 divided by 100 actually 99 millimeter. So, that means in 216 days, 216 days will be required to achieve 99 millimeter of settlement. And similarly, if you want to find out 50% settlement, how much time it will require, that we can change only this, instead of T 90 I can use T 50. If it is mentioned that 70%, then instead of T 90 I can use T 70, like that any percentage it mentioned, accordingly I can find out the T, and then I use this equation to find out the time required. So, this way one can find out the time also. So, this problem actually is a complete application of all those things, consolidation data, from there calculation of CC, and then applying log formula find out the total settlement, and then further applying the time factor equation I can find out the time required to achieve certain degree of consolidation settlement in the particular layer. So, like this we can do the problem, but once again let me go back to the problem. So, this problem also Similarly, so this problem also in addition actually this problem in addition that here actually it is mentioned only total consolidation settlement delta C. So, we may need to find out delta I also. If you want to find out delta I, then again I could have drawn the Smartman influence chart, and from there I find out I here, 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 and then if I know the E value here, E value here and E value here, then again I can find out the delta I. So, then calculating these two together, I can find out the total total settlement of the total settlement of this footing. That means, load is applied through this footing. That means, whatever settlement is taking place because of immediate or consolidation, that will be ultimately that much amount footing will be settling, that will going downward. So, that if you want to find out the total, then you have to find out in addition to that whatever we have done, you have to use the Smartman method, which I have initially discussed, and this is the way first corresponding the footing size, draw the influence diagram, then find out I at respective places, then sigma I multiplied by H divided by E, and by that I can find out the settlement. So, this is the way one can find out the complete problem. So, with this I will only one part is left actually, that may take a very 1 or 2 minutes, that not much information is available. That is, I have initially mentioned that settlement is a combination of 3 parts: initial, then the consolidation, and then your secondary compression. That secondary compression, not much things are available, I could have brought today, but there is some empirical method to calculate, and sometime I will take that one, and is not very that important also. So, there is another part in the otherwise the settlement of footing considering various aspects I have already done. So, with this I land here consolidation chapter, and in the next class onwards I may take the soil exploration and different field testing, etc. I will take in the next class. Okay. Thank you.